Good morning and welcome back to what is now episode 5 of Oakland's guide on how to build a data platform. My name is MLG and this is the video series that is accompanying our physical, actual written guide, which you can go ahead and download from the link that's in the description on this video if you want to. But let's get into what we're going to talk through today, because today we're going to talk through data ops and automation. I've entirely neglected to write the title up here, so we'll do that now. And let's talk about what we mean by data ops. Because data ops is a word that has come out of the very well-established word of DevOps, which is developer operations. And data operations are the processes that support getting your data into creating your platform and then moving the data about once it's inside your platform. And I don't have to sell you on automation. Okay, you can sit there and you can quite competently for yourself, I think, believe that if we automate many of the processes that are inside your data platform, then you're going to be more efficient and you're going to have a good time. But we thought about the value that comes from your data platform, and we've thought about the solution architecture that you're going to have to implement in order to have a platform that brings you that value. So let's get our teeth into some of the more technical aspects of your platform. And let's talk about the processes inside it that you should be planning to automate from the outset. Bringing ourselves back to the data platform that we've had for the entirety of this series, let's go ahead and draw a diagram. And we can use this to understand all of the different processes inside the data platform that you should be planning to automate from the outset. Some of these are more complicated and we'll dive into them a little bit deeper, and some of them are pretty easy to explain. So like the easiest one to explain is your code testing. You will have some repo, a repository somewhere that contains all of the code that you are either going to use to build your data platform, which is something we'll touch on in a second, but also all of the code that you will use to move the data around inside your data platform. And this should be tested. This repo itself, this repository, if you're not familiar what it is, go and ask your development team and they'll tell you. But it'll be somewhere like GitHub or GitLab or Azure DevOps or something like that. Inside there, you should have automated processes that test your code. And they can test it in a number of different ways. This is quite a high-level discussion aimed at non-technical audiences, so I'm going to cover things like unit testing and integration testing and linting, and we're going to kind of like wave our hands at what they do. If you want a specific, more low-level discussion of what testing packages we recommend, then hell, click the link in the description below, get in contact with us, and we'll tell you. But suffice to say, you should be doing testing on the code. So these are things like unit tests, where you test that the code is internally self-consistent, so that any changes that you make don't immediately break just because the code is incorrect. All the functions that you've written, all the classes that you've written, all the methods that you've written, they all work nicely alongside each other. And you do that by effectively mock running them in a pipeline and seeing if anything breaks. And if nothing breaks, then you're all gravy. You also might do some form of integration testing where you mock up data formats and you see how your code is going to work when it's actually deployed in the platform by feeding it fake data or even subsamples of development data. But that's an argument that we can get into another time if, like I said, you send us an email or give us a ring. The final one that you want to do is you'll want to make sure that your code is readable and conforms to all the coding standards. So you'll do a thing called linting, which is nothing to do with washer dryers. What it is it's just making sure that your code is formatted nicely and in a consistent way, because ideally, the ideal for me, and this is a philosophical position from like a developer and software development standpoint, I want you to be able to pick up any piece of code inside your code base and not really be able to tell which developer wrote it. If you have developers who have like a very unique persona to their code, then that's not always a brilliant thing, because you want to be conforming to a standard. And this package of testing that you run in an automated way on something like a virtual machine that you provision is one form of data ops. You should be doing automated security scanning. And the reason for that is twofold. You want to make sure that the code that you are writing and the things that you are provisioning into your platform don't have any vulnerabilities in them that can be exploited by bad actors. But secondly, you want to make sure as well that all of the packages, so your code isn't written from whole cloth by developers. They pull in packages and libraries from other code bases to help them do things that people have already pre-written. And you should be scanning those packages to make sure that they are clean and make sure that they don't have anything in them or any vulnerabilities. And there are tools that you can use to do this. NPM Audit is a really good one if you are pulling in things like node packages, and that gives you not only vulnerabilities, but also warnings as to what might be depreciated in the future. Those are quite well understood tools by the developer community, and they can be loaded into this automated testing package to help you monitor the code that you are pushing into your platform. The final version of automation that I want to talk about is called infrastructure as code. And we're going to take a slightly deeper dive into what I mean when I say infrastructure as code, because I'm talking to a non-technical audience here, and I throw around the acronym IAC, infrastructure as code, all the time. So I think it's worth explaining what it is. Now, your data platform, this is going to sound dumb, but I'm going to say it so that we're all on the same page. Your data platform is made of many different components. And they are provisioned generally in the cloud. So at the front of it, you might have, and I'm going to use Azure as the example here because that's just where I happen to have my most experience. But at the front, you might have something like Azure Data Factory, ADF, and then you might have some storage containers here. You've got some storage in the middle, and then you might have something like Databricks on Azure. And then you might, on the end, it's not going to fit, but you might have Power BI. All of these components are just objects that get deployed by the cloud provider when you ask for them. And one of the ways of doing that is to go to Azure in what they call the Azure portal. So you go onto Azure's website, portal.azure.com, and you click and you say on the button, yes, can I have an Azure Data Factory environment, please? And that sets off a chain of things in the background that go away and provision that resource. However, that's quite annoying because you will want to provision lots of things very quickly, and you will want to be able to monitor what those things are and change them in a very fine-grained way if new versions come along, or you need new functionality, or you just need extra parts or connectors or whatever. We're missing out a whole load in here, right? We've not even considered how these things are networked together. So there's a whole nest of virtual networks and private endpoints and network cards and all kinds of shenanigans going on behind the scenes in this thing that you will need to create and configure for yourself. The average data platform might have, hundreds of components in it, and you sure as hell don't want to go through and click through every single component to configure it and make sure that it's made in exactly the right way and wired up with the correct authentication. That just sounds like, well, obvious madness, to coin a phrase that we've been using a little bit on this series. So you have a thing called infrastructure as code, which is commonly referred to as IAC. And IAC is just a really good description of what every single component is. So the description of the component for Azure Data Factory will contain things like, what do you want to call it? Where geographically in the world, which data center would you like to put it in? What connectors should we have? What compute type do you actually want to run Azure Data Factory on? Because it's not magic, it's got to run somewhere. Are you bringing your own virtual machine that you want to run Azure Data Factory on? And if so, where is it? What sort of virtual machine is it? What networking does it have? Yada, yada, yada. That's called a self-hosted integration runtime for the nerds who are keeping count at the back, but we don't have to worry about that. Or do you just want like Microsoft to provision that? All of those things, all of those details are written down in IAC, infrastructure as code. And there are different IAC languages or different IAC dialects, as you'd kind of expect. Like you put a whole bunch of nerds in the room and you ask them, how best should we do IAC? And you get like 5 different answers. So Azure has its own. Azure has a thing called Bicep, which is a pun because Azure Resource Manager, or ARM, is the old way of doing IAC for Azure, And the better form of ARM is Bicep. It does actually stand for something, but I don't know what it stands for. And you can use Bicep templates to provision resources in Azure, but there is also a language called Terraform, or a dialect of IAC called Terraform, which is cloud agnostic. And you can actually use Terraform to provision resources in Azure, but also in many other cloud providers like GCP and AWS. And actually, if you come to us and start talking about cloud environments and data platforms, we will probably recommend that you provision your resources in Terraform, because that gives you the flexibility down the line to be a multi-cloud platform if you want one. So just to recap, this is of course code and should be tested, monitored and linted in the ways that we talked about previously. And it's not uncommon to have one or more repositories of code that have, so you might have all of your data pipelines in one repository and then all of your infrastructure is code in another one, or if your platform's small enough, they might just coexist inside one repository, and you use your CI/CD pipelines, your continuous integration, continuous development pipelines, which is basically just a really fancy way of saying automated processes. You use those automated processes to keep your infrastructure up to date by referring back to the IAC when you need to, and you also use it to deploy out into your pipelines the code that transforms your data. Now, the final thing we're going to touch on is the vexed question of environments. Because when you build a data platform, you need to think very carefully about the relationship between the people who are building the data platform. And we'll put them down here. Give me my eraser. Let's get rid of this IAC, it's in the way. So we've built ourselves a data platform. And when you've got your developers down here who are actively making changes to it all of the time and pushing in new data and so on. And then you have your business users out here. Let's draw them in red because they're important. And they are consuming data and insights and things from this side over here. Now, they're looking at the Power BI. Let's pretend we've built this data platform. So we've got, recall, ADF, some storage, Databricks and Power BI, and we've got data coming in over here. It's just, I don't know what this is. Let's just work in the abstract for now. We have data coming in over here. It gets transformed and pulled in through ADF. Some stuff happens in storage. We figure out some transformations in Databricks, and then we surface insightful KPIs through the Power BI dashboard that lives over here. And they're very, very happy with it. We've got business users over here who have a smile on their face. They're very, very happy with the insights that they're getting. But then one day you come along and you say, well, actually, I think I've got an improvement. So this is our developer over here. And they think they've got an improvement. That actually what they think is that there's a better way of ingesting data in ADF. So now this is just some notional example, but let's pretend that they've thought of a better way of doing it, or at least they think they have. And they make a change in ADF here and it breaks it. Suddenly we have Azure Data Factory not working. And so we're not getting the best data. We're not getting the most up-to-date data. Our KPI falls behind, and that makes our business user very sad indeed. What do we do about this problem? Because this is a very common problem in software engineering, never mind, or just technical engineering, never mind data engineering or software engineering or any subset of how humans use machines to bend the world to their will. This idea of making changes in the actual product that is being consumed is a big philosophical one, and one that's very easy to address by having multiple environments. So when you deploy a data platform, in general, you will have more than one environment. And we might call this one on the top, and this is where you're going to start to click in and be like, oh yeah, of course that's what he's talking about. Blah. Of course MLG is talking about that. Well, this is production. So you generally have a production environment, and that is the one that you don't touch unless you're really certain that the changes you're about to make are going to work. And how do you become really certain that the changes you're about to make are going to work is that you have other environments where you test them. So we might have a whole nother environment down here that we call test. And that will let our developer play about in a test environment. And when they know that their data is working and all the transformations and the changes that they have made are happy with each other, what we will then do is promote those changes using, remember, our pipelines, that CI/CD thing I was talking about earlier. This is how you do that. You just provision a virtual machine in the cloud and tell it the changes that you want to make to the platform, potentially involving your IAC or potentially involving code changes. And then you apply those changes from one environment to the next one. And because you've tested your code down here in test, well, that keeps your business users happy because you have observed that whatever you've written, those automated processes, or maybe you've got some kind of test Power BI down here, you can see as a developer that the KPI remains the same, even though you made changes to your test Azure Data Factory down here. You may go even further than this and actually have 3 environments, one for development, one for testing, and then one production environment. And the reason that you might do this is this allows you to have a much slicker workflow than just test and production. Because let's imagine for a second that we have multiple developers. So we haven't just got one person in green here, we've got many of them. And they are making lots of different features all at the same time. Somebody's working on making ADF quicker, somebody's working on a new compression algorithm in the storage, somebody's building out new KPIs in Databricks, and somebody's faffing about with the Power BI colors. And that's making the business user very annoyed. But that's a story for another time. When you have multiple people mucking about in one data platform environment, it becomes very, very messy and very, very difficult to figure out if any of those features in isolation are going to break production when they get promoted, because everybody's changing things all at the same time. So you might have a development environment where they can play. This is where your developers bring new features in, it's where they prototype stuff, and it's where they build new things that will eventually get promoted into production. Then in your testing environment, you promote one feature at a time sequentially to make sure that when you push that feature into production, it won't break. And test has things like big loads. So you might take your test environment and actually wire it maybe into a facsimile, or maybe even actually the data that your production environment has, and the full load gets exposed to test, because there are some bugs in some features that don't actually become apparent until you point petabytes of data at them. And at that point, things start to fall over. But you won't know that unless you have actually load tested that feature in some way. And so you can now have 3 environments where you have development down here, which is just like the Wild West. There's all kinds of crazy stuff going on in development because that's where the developers are playing and iterating on new features. Then test is a pretty clean environment, which looks a lot like production, but maybe with 1 or 2 significant changes to it that are about to be released into production. And then once we are happy with the features that have been tested here, we can promote them into production, know that they work safely, and keep our business user happy. Do you know, I think that's probably enough for this week. We've covered quite a lot there. Basically anything that can be put in a data platform and automated, we have lightly touched on in one form or another. We haven't quite mentioned logging, but that's, I think, for later. Or indeed, you could just get it in the data platform guide. This 100-page guide goes into way more detail about data ops and automation and CI/CD than I can possibly touch with a whiteboard and 15 or 20 minutes of your time. So, as always, you should go to the description to download that guide. You should subscribe to this channel if you are enjoying this series. I've been MLG, and I shall see you in a week.